Hello everyone, this is Dr. G. Karthik Reddy working as Associate Professor in the Department of EC, MLR Institute of Technology, Hyderabad. And today's session topic is problems on cross-correlation function. Okay, today's overview of the session is problems we are going to discuss on cross-correlation of two sinusoidal signals, problems on cross-correlation of two independent process, next problems of cross-correlation of exponential random process. Okay, now first we will discuss on the two sinusoids. Okay, two sinusoids means two different sinusoids. Here we discuss the two signals x of t equal to a cos omega naught t and y of t equal to b cos omega naught t plus psi. Okay, find the cross correlation function. Okay, cross correlation between two signals. One is a cos. A is the constant, that is amplitude. For cos is a function. Omega naught is angular frequency with the time t. Okay, b is a constant. Cos omega naught t plus tau. You have to find out the cross correlation function, that is Rxy of tau. Okay, this is a problem solution related to this. Okay, we know the definition. Rxy of tau equal to expectation of x of t into y of t plus tau. Okay, first you have to simplify x of t and y of t plus tau. X of t we know from the problem that a cos omega naught t, and y of t, in place of y of t substitute t plus tau, then you are going to get b cos omega naught t plus tau plus phi. That is the b cos omega naught t plus tau plus phi. Then what you have to do? We have to apply the product of both. When you apply the product of both, okay, then what you are going to get? Here you are going to get expectation of a square into cos omega naught t into cos omega naught t plus tau plus phi. Okay, now you take the a square outside, a because expectation of constant is constant itself. Then the remaining terms, this one you consider as alpha, this one you consider as beta, then cos of a into cos of b, or 2 cos a cos b form, that is cos of a minus b plus cos of a plus b. Okay, you apply that to the above expression, then you are going to get ab by 2. ab by 2 is a constant terms, then cos of a plus, okay, a minus b, okay, this one you apply it, then cos of a plus b, you apply the terms alpha plus beta, alpha minus beta, you simplify it, then you will get cos of, this term will get cancelled, you will get cos of omega naught minus omega naught tau minus phi. Okay, now remaining term you are going to get, here what you are going to get, ab by 2 expectation of cos of, okay, cos of what you are going to get, minus omega naught tau, okay, omega naught tau minus phi. Now next here what you are going to get, cos of 2 omega naught t omega naught tau plus phi. Okay, now what we have to do, we have to simplify it further, then you will get the resultant of this answer. Okay, apply the expectation, apply the integration on both sides, then what you are going to get, cos of minus theta is cos theta itself, then you apply this term, then integration if you apply, then here you did not consider any which is a uniform random variable. Here it is considered theta is a, for example, phi is a uniform random variable which is defined over the interval 0 comma 2 pi. Then you can simplify it and you can solve the condition. Just is asking only the Rxy of tau, you can solve up to here, it's enough. If they ask further, phi is the uniform random variable, then you have to simplify it further. Now second question, the cross correlation of two independent process. Okay, here x of t equal to some exponential term they given, exponential decaying term, a into expectation of minus alpha into t for tau, what is that, for t greater than or equal to 0. Here a is a random signal with expectation of a square equal to tau. Then what he is asking, then find out the cross correlation function by considering y of t equal to b into minus alpha into t. Now again here we are having cross correlation function Rxy of tau, then what you have to use, Rxy of tau is equal to expectation of x of t into y of t plus tau. Now again same procedure, a into e power minus alpha t plus b into e power minus alpha into t plus tau. Now AB is constant, take outside, then what you are going to get, expectation of e power minus alpha t, e power minus alpha t minus alpha tau. Now we have to simplify it further, then what you are going to get, expectation of AB is constant, take outside, expectation of e power minus 2 alpha t into e power minus alpha tau. Okay, now this is the formula you have. Now next, this is in the form of, now you can apply the expectation for this, you can apply the expectation for product of this, then you are going to get the resultant of cross correlation function. Okay, now next, when you are considering the independent, and one more thing he is considering, for example independent process, then 0 mean you are having, both the terms become 0, then the cross correlation becomes 0. Next, same thing, expectation, then what you are having, the cross correlation function of that, you can check it, the solution of that, x of t equal to e power minus alpha t, b, you apply the product, then e power minus b tau is constant, take outside, then integration minus infinity infinity e power minus alpha plus beta into t into dt. Here you consider this as a constant k, constant k, the integration minus infinity infinity, this term is of solution is 1 by k, then rxy of tau equal to e power minus bt, which is into 1 by alpha plus beta, which is k is equal to alpha plus beta, we assume, then substitute that, then you are going to get the resultant of that. This is a resultant of cross correlation function between two sinusoids. This is a cross correlation function we are going to calculate. In this way, we have to calculate the resultant of that. Any problem, first you have to identify the expression. What is the basic formula of cross correlation function? If you know the cross correlation function, then x of t and y of t are two different process or two different signals. It may be either sinusoidal signal, or it may be either exponential signal, or it may be either any trigonometric signal, or it may be any log signal, or it can be any function. X of t and y of t may be two functions also, any function. It may be any standard signals also it can have, like it may be either x of t may be the unit step signal and y of t may be the some ramp signal. Then they'll ask the relation between the cross correlation function for these signals. It may be any standard signals, or one standard signal with its some sinusoidal signals, or one standard signal with one exponential signal, or any periodic signal with another periodic signal. These are the different types of examples mostly they'll ask in the exams. Thank you.